let's get started. It's I've got 1:30, and we got a full agenda today again this afternoon. And don't forget the trivia tonight. Stay for the trivia. It's a lot of fun. We've done that a number of times, and for those who are here, there is drinks, free alcohol. It is included. So, okay. So, Syed Ahmed is a PhD student at George Mason University and an engineer specializing in model-based systems engineering, software development, and digital twins. His work focuses on integrating MBSE methodologies with AI and enhance system design, predictive analytics, and automation. So here, Syed.
Hello, everyone. Good to see you here. My name is Syed, and I am a PhD student at George Mason, second year student, in fact. And I'm going to be presenting on how to integrate machine learning models within systems engineering design in SysML for system simulations. This is just a little bit about me. I've actually had a background in software development, working with multiple coding languages, developing APIs and stuff. So I only recently, a couple of years ago, transitioned into systems engineering through my PhD, and working towards creating digital twins, integrating different methodologies, and different things. So the agenda here is to talk about a certain problem that I've been working on, a certain project, I guess you could say, and why that problem came to, how that problem came to me, and how I tried to use AI, ML, or rather AI, machine learning, predictive models, anything you like to call it. How I used it to try to solve that problem, and how to integrate the system design methodologies and the machine learning development methodologies together to create an architecture actually that would help me solve this problem. And I'll also demonstrate it using a case study. So the acronyms used in some of the diagrams you'll probably see is PM, which stands for predictive model. It can be your machine learning model, your AI model, however you want to call it, and your SM is system model. So the problem that I had was I encountered a couple of systems that were incompatible with some simulation software. We couldn't exactly connect these systems to simulation software such as Magic System or Systems Architect. That's one of the primary tools that we use. And we had actual difficulty in having these real life systems connect to a simulation software for some real-time data simulation. It could be anything, different problems such as lack of APIs. For those who don't know that, it's application programming interface that allows you to create a data bridge between your system and your simulation software. Maybe there could be some legal concerns, some privacy concerns, where some companies, they do not want to open up their data points to your system simulation. So when you've got a problem like this, how do you model and simulate these systems? So I've been working on this problem for a while now, a couple of months, and initially I wasn't too keen on using AI ML to solve this problem. I didn't want to give in to the FOMO of going into AI, trying to solve this with AI ML, and I wanted to be that last bastion holding the ground against the AI infestation. But I was humbled pretty quickly, because as I worked on different AI ML projects separate to this problem, I realized that there is a potential solution that I can, there's a feasible solution that I can actually achieve if I were to bring in machine learning models here. And that feasible solution was, my machine learning models can actually act as a surrogate, as an alternative to those data, those incompatible systems that do not allow me to connect, their data to my system simulation. So can I take these machine learning models, train them on that incompatible systems data, and instead use those models as a surrogate, as an alternative, as a data generation entity in place of that incompatible system in my system simulations to run those real-time simulations. So the idea was pretty cool. I remember just thinking about that, and I wanted to see how I can achieve that. Being in a lab all day actually gives you like time to think on different stuff. So opening up different avenues for systems engineering, bridging it with data science, always cool. So I started to look into more into how AI ML is being used in systems engineering. Went to, Google Scholar, literature, research papers, and saw different people working on different stuff, validating model behaviors through ML models. Some people are working on predictive maintenance. I actually went to a couple of colleagues of mine who were like, yeah, we're really excited about, SysML v2 that's supposed to be coming out soon, and we can, use LLMs to generate our system models. And I was like, okay, you just, you're really into it. And at this point, I was starting to, feel humble, like, okay, maybe I did make a mistake maybe by not embracing the AI ML, aspect sooner in our, MBSE systems engineering work. So I got to it. I went back to my problem. Okay, we have these traditional MBSE simulations that require real-time data that is coming from these real-time, physical systems in the real world. If I cannot get these real-time, these real physical systems to connect with my system simulation software, how do I, try to solve it? So need for a solution that enables realistic simulations without actually connecting, the physical system to the model. And the way I did it was I brought in two different methodologies, one of them being the predictive model development methodologies, which is CRISP-DM here in this case. This allows us to create predictive models, machine learning models, and it has a couple of number of steps. You acquire the data set from your system, clean it, pre-process it, define your target variables, feature variables, and select whatever models off the shelf, for me in my case, off the shelf models you want to use. You train the models, you validate the models through different metrics such as root mean squared error, which is like the comparison between your your testing data and your training data, and R squared value, which basically allows you to gauge your model variance. So this was the methodology that I would use to create a machine learning model. Okay, great. How do I bring it into my system development, which is a completely different thing? So I would create a system model using a different methodology, systems architecture, laboratory object-oriented methodology, also called SALOM. I will use this to create a system model on, using SysML in Magic System of Systems Architect. And, again, it has different steps. You define your mission, operational concept, use cases, requirements. You develop your structural view, your behavioral view, and, you run some simulations. Now, at this point, I added a new step, design data flow pipeline in this methodology. And this was the step where I wanted to bring in the model that is trained, the predictive model that is trained using CRISP-DM. And the way I would do it is through this architecture. This this is like the moneymaker slide for my problem solution. The way it works is that I have a server, a simple server that created using Python on Flask, and I host an n number of predictive models on that server. N equals 3 in this case, in this diagram. And each predictive model would get a unique HTTP route for each model. You can access those models through these HTTP routes, which are, through HTTP IP address and a unique ID. And your system model, the one that you created that allow you to run system simulations, would reach out to these predictive models through a unique JSON post request. So it will send a number of data, command, integers, values, whatever you wanted to send to these predictive models. And these predictive models would receive this data based on their training, evaluation, and all that stuff. They would put out an output, and that output will go back to your system model. And as you continue to run more and more simulations, more and more loops in simulation, those models will those predictive models will effectively start to give you out a bunch of data that your system model or your SM will start to realistically run some simulations on. Now, I remember, sitting in my university dining hall and just writing it down on my notebook, but this was all well and good. I had created an architecture, something that I could actually work on, integrated two different methodologies together, but how do I, test it out? How do I, show that this can actually work? So I went to a couple of different people to see if I can get a sample case study. One of them was our biology department. I talked to them. They were like, okay, here's a project for you to work on. This was an automated insulin delivery system for a patient, and took multiple hours for me to get, understand how this worked, because again, I'm not a biologist. They told me how everything worked, and I just boiled it down to a very simplistic, terms. So there's a patient who has diabetes. He has this continuous glucose monitor, a CGM, that is hooked onto his body that measures his glucose at every 5-minute intervals. And of course, he also has an insulin pump connected to his body, and all of these two devices are connected to a mobile app, which is like a medical receiver. When the patient's glucose levels gets too high, the insulin pump injects a dose of insulin to offset those high levels. If the patient's insulin glucose values get too low, he just goes out and eat a carbohydrate-rich meal to offset those values. Now, this seemed like a prime candidate for me to test my architecture, because here we have got in this scenario, the data generation entity is the biological patient. And of course, I cannot exactly hook a biological patient to my system model. And the data, so what this biology department does is that when they run these system simulations, they actually log on to the company's website, for whoever creates these devices, and they get a CSV file every 3 or 4 months, and they run some simulations based on that CSV file. So I took those CSV files and I started training some predictive models. I took, these were time series data. So every new row is like a 5-minute interval for their diabetic patient's glucose levels. So I took that series data, I divided it into training data, testing data, ran some, basic pre-processing, trained 3 different machine learning models, LSTM, GRU, and XGBoost. The way I decided to use these models was I looked into some papers and see what are the ideal models that you would use to train time series data, and these were the ones that came to me. Now, I only did some basic level training. I didn't do any advanced training like hypersegmentation or tuning of hyperparameters that you would do, that a data scientist would do. The reason why I didn't do that is because I wasn't interested in solving the case study. I wasn't interested in solving the prediction problem, the glucose problem. My concern was solving an integration problem. I was concerned with integrating these machine learning models. So I just needed some models to run my, my experiment with. I took some testing data and I ran some basic level validation just to say, okay, I followed the methodologies to a T. And even based on basic training, the values I got were pretty good. The root mean squared error was between 3.15 to 3.20 for each of them. R squared value between 0.97 to 0.98. Once these PMs were developed, I uploaded them to a server, and there they stayed until I went towards creating my system model. I created this is a very a small chunk of my operational concept. The operational concept was a much bigger diagram. I just couldn't fit it inside, so I just took a small piece of it. It just shows you an automated insulin delivery system that has different items, different artifacts attached to it, CGM, your medical receiver, insulin pump. And instead of that user that gives you the glucose values at every 5 minutes, instead of that, we have an insulin glucose predictive model attached, as a composite block to the system context. I created this use case based on many meetings with the biology department, trying to understand how each of these components they worked in tandem, because I was creating a system model for a system that I was completely unaware of. I had to have a lot of these meetings. So I created these requirements that would suggest, okay, your system model should be able to record these insulin and carbohydrate entries, because apparently insulin and carbohydrates are the 2 values that you would need to run this. Furthermore, the system model should be able to communicate with your predictive model. There should be a third-party user who should be able to use a GUI through, within the system, within the model, to run some tests, some experiments, and they should be, displayed through a graph or something. So these were just like my basic level requirements, just doing some housekeeping to, before I start actually building the system model. So this was my system model, the automated insulin delivery system. It has, a CGM attached as a composite block. it has a value property, blood glucose level. This was the basic default level of a patient, which is at 86 right now. We just kept it at 86. We also have a medical receiver, which has insulin and carbs as value properties. These were kept at 0 because these were supposed to be given by these will act like, okay, if a user's blood glucose value gets too high, he injects, an insulin at runtime. So these were going to be initialized at runtime. So they were kept at 0 at the beginning. And some, created an internal block diagram to just see how those values work. This was the process flow on how I went about creating this. The user would use a GUI to send an initial value of insulin and carbs. These would go towards understanding how the medical receiver and insulin pump works. The values would ultimately get converted into signals and travel into the predictive model that is hosted outside the system context on a separate server. The predictive model will take these values, run some internal computations because it's a black box. I don't know what it does, and it will output a certain blood glucose value of that patient 5 minutes down the line, as in the future. And that value, that blood glucose value, will then become the current value. So every time the predictive model, outputs a blood glucose value, it takes in the input of the previously predicted value. So the previously predicted value becomes the input for the next value. And this is just some under the hood kind of stuff that I did. This was the important one, creating the activity diagram for a glucose model. You can see 3 different values coming in signals. You've got your blood glucose values, you've got your carbs, you've got your insulin. All of these 3 comes together and creates a 1:3 input array. Once this array is created, a connection to the predictive model is established, and this is done through the architecture that I created using the unique HTTP route. It creates this, it accesses this route, and this input array, the 1:3 input array, is converted into a JSON post request sent to the predictive model through the HTTP route. The predictive model takes it, evaluates it, sends a predictive value of the patient's blood glucose 5 minutes down the line. And once the simulation starts turning into a loop, the output from this becomes the input for subsequent simulations. So effectively, I just replaced the entire patient with a predictive model in my simulation. And I added a GUI for like that mobile app so that I can, whenever the graph shows, okay, the glucose values are getting too high, I simply add in an insulin value, and the glucose values get offset those high values. Similarly, if they get too low, add some carbohydrates to offset those values. So the simulation we're running, the integration at this point, I could say, was successful. Now, I debated having this slide over here because, again, as I said, I was solving an integration problem, not a prediction problem. Regardless, I kept it here because I just wanted to show you how the predictive models that I trained actually worked against the actual diabetes, the glucose values of the diabetic patient. LSTM immediately flatlines after a certain time. It does not do a very good job of predicting. GRU does capture some sort of behavior, but the best one that actually works in this scenario is XGBoost. So if I were to actually go back and train these models, I would definitely choose XGBoost, but then I would also train some hyperparameters to actually get a much closer predictions. Because again, I wasn't solving a prediction problem. I was solving an integration problem, which was validated by just the connection and receiving the values in the previous slide. And then just this experiment just really helped me understand how machine learning models can help trained on data sets from third-party systems can indeed serve as a replacement for data generation in system simulations. The system fidelity is kept intact. That system, that aforementioned incompatible system, you're not going to be opening it to data points or anything. So the fidelity of that is kept intact. Your privacy and logistical concerns are met, and an AI/ML model is now effectively being used as a substitute for that. And again, not solving the case study prediction problem, rather solving an integration problem. So in conclusion, just wanted to again reiterate how just bringing in a predictive model as a functional component within your system model can just open up a ton of different research avenues. And one of the things that I really wanted to do in the future was, because I've been working on static models, but reality suggests that static models won't work because a person's glucose level right now isn't going to be the same 10 years down the line. So maybe you can use adaptive model that continuously update itself based on new data, and use that as a substitute instead of static models. And of course, I would definitely need to work on more case studies to actually develop a truly modular solution that could, I can just give it to anyone and they can use it on any case study or any problem rather than just a diabetes glucose patient problem. And yeah, this was just, that was my presentation. Thank you for listening.
So do we have questions in the room? Questions?
As you've been going through this research, did you come up with any sort of, so as you've been going through this research, did you come up with any industry standards, mathematical models for how they have been predicting this stuff previously? And use that as kind of control?
So in terms of, so when we were creating these models, we were creating it particularly to predict glucose, and there were already systems, predictive models in the industry that were created specifically for targeting, glucose values. But the problem was they were very generic. They were not specifically created for one patient. So if I'm targeting one specific patient like you or someone else, like I would need your data rather than a generic pool of data. So this was one of the things that the biology department told me, like, hey, we already have these predictive models that you can use, instead of training your own model, just pick up a pre-trained glucose model and just use it for system simulations. I was like, okay, but if I want to do it for someone specific and certain individual, I would need their data. Like, I know in hindsight, maybe it was a correct idea, maybe it was not, but that's one of the reasons why I actually went to a patient instead of taking a mass-produced glucose model, a generic glucose model that is already there, because there are a lot. Biology has made a lot of advancements.
Yeah, I think it'd be fun to compare your results to, whatever that industry standard is.
Right. Yeah, could be, definitely. But again, I was solving an integration problem. I wasn't exactly concerned with, where. Maybe I definitely should. As a PhD student, I should be, but this was just a first step. So yeah.
Any question? So how much longer do you have in your research time, you think?
Well, I am in my second year. I've got 3 years left. So
Okay. Oh my gosh. Okay, you're just starting.
Yeah.
Yeah. Yes. It's a long program. Yes. Any other questions? Let's thank the speaker again. Thank you so much. Okay, we'll be setting up for the next presentation. I assume there were no comments online. It's always a bad assumption. Okay, there were none. Okay. Okay. So the next speaker is me. Hello. There we go. So I'm going to do something a little different. Let's see, what is this? This is not what I want. What was that? Okay. Somebody shut down my tab. It never fails when you have something all set up and then no. Here we go. I knew I had it someplace. Okay, so. So we'll start again in a few minutes. Got to wait until the other session breaks in case people want to move over back and forth. Smoking while it happens. Smoking while I got it. Sorry, you say smoking while you got it. Smoking while you got it. Yeah, smoking while you got it. Has anybody watching for all mankind?
Yeah.
On Apple Plus.
Yeah.
Isn't that wild? The amount of scenes you see of people smoking, and that's exactly the way it was. I still remember I was at Los Alamos at that time.
Oh, you're talking about like the early seasons.
Yeah,
Like
yeah.
they're, I don't know if the show is finished yet or if they,
Yeah,
if they're.
I'm just
starting
watching
to
the first
do-
season. Just I'm
Start up. Oh, yeah,
first
the
thing.
first couple of seasons, yeah.
But it just hit me, the smoking thing, it's just so big.
People were smoking in mission control and launch operations, you know.
Well, I'd be at,
I mean, not when I was there, but
I was at Los Alamos in late seventies, early eighties. And I usually, I'd be out in character, coffee cup, because people just use it. Yeah, especially guys from Livermore, all the guys from Livermore smoke, I don't know what it was. Yeah. We were healthy at Los Alamos. It's funny when you mentioned about talking about your first computer and stuff like that. It was 79, you said?
yeah.
Yeah, that's when I first got on the Cray, and we had two MIG-5s.
Oh, wow. Twice as powerful.
I think we ultimately got, one was like 8 before I left, but it was,
I mean, my wife
changed so
has
fast.
1,000 times more power than that first machine that I touched. We're gonna look at the, it was the onboard computers on the lunar module had like
Kilobytes.
yeah,
It was kilobytes.
like 1,000 K of RAM or something like that. No, well, not about that.
I think it was less.
10 K.
Yeah, it was like in the
For one
20
name. Like something
really small.
like, you gotta think, what exactly were those computers doing? That little, I mean, it's all machine makers, so it's very compact. What were they really, what was their real job? So it was supposed to be auto landing, you know, and then about a minute or so before touchdown on Apollo 11 is when they flipped it off autopilot, and, you know, and Armstrong had to fly it yourself.
Yeah.
You know, because they were getting too many errors. See your IBM representative for more explanation of this error.
By the way, what martial arts thing?
It was, well, I don't do it anymore, but it was taekwondo and also having black belt and head partner style, you know, and karate.
Oh, okay. I was gonna say, I heard kata. And
Yeah, well, and I just use that because most people know that term, you know,
Yeah.
that's not what you call it in Korean style, so I focus more on the Korean style. And then a lot of combatives too, like, you know, the Marine Corps martial arts program, I was an advisor on that for a couple of that was just a lot of yeah, remember the colonel telling me one time, the head of the program, he's like, we really gotta get on to safety, we got first of all, there aren't many Marines to start with, and too many of them are getting injured. You know, hurting each other because they're out of control. And I'm sure you got to teach them yogurt sparring. And he's like, yogurt sparring? I said, yeah, light and light. You know, they get too carried away and they start beating each other to a pulp, and they don't really realize that stuff works. You can put somebody down.
I have black belts in different styles.
Yep.
And the first one was non-contact, this one, contact.
Oh, yeah, yeah, exactly.
It was like, oh my gosh,
Gear.
real different.
Absolutely.
Very different AM.
Yep.
Oh, gosh. How are we doing here? Do you have the, you don't have the, okay, just have another couple minutes. And get started.
Yeah.
What's that? Kind of interesting. So I need to stand about here. I'm just looking.
Okay, I have 2 o'clock. So why don't we get started for the next session? We're starting again. Okay, I hope everybody online can hear. By the way, again, please, if you have comments or questions, please add them in the chat if you're online. We'll try to keep track of that as well. So I'm going to talk a little bit about LML v2. We've been actually developing LML v2 since we started LML v1 in a sense, because as you do the point releases, you want to evolve towards that next version of the standard. And so this is an evolution. This is not a revolution. Sorry. but it does represent over a decade of using the standard, understanding the standard, and making adjustments to it as we went through it to improve the language. You know about us a little bit, so a little bit about me. For those who don't know me, and a lot of people do, my PhD is in physics. And everybody wonders, how did I get to systems engineering? It was a long, circuitous route through TRW, Rockwell International, SAIC, and then finally my own company to do systems engineering. So we've been in business for over 30 years. We were an intentionally small business. People always say, well, why haven't you grown? Because I worked in big companies and I don't want to. Okay, again, so just make sure that's out of the way. And so, but I do have an ESEP from INCOSE. I'm an AIAA Associate Fellow and a member of the Systems Engineering Technical Committee at AIAA. So I'm pretty involved in systems engineering. So the goals of SysML v1 were to look at, leverage that work we had done in the past decade and add that to the baseline, determine what was appropriate to add to the baseline. Because one of the design constraints and concepts we've had with LML is we want to make it as simple as possible, but be able to do what we need it to do across all systems engineering and program management. Okay, so what we want is an elegant language, not a simple language, an elegant language. In other words, that irreducible set of information that you need to make decisions, particularly. So this is the essential elements of information for systems engineering and program management. So again, we only wanted to include the entities, relationships, and attributes that needed to make a better representation of that entire life cycle. So we recognized there were a couple of places where we had been light, and that's why we added the appendices to begin with, and we wanted to go beyond that. The other thing we wanted to do was we'd been working with a group who was developing a standard in InnoSlate for ASME. It's a plant standard, and they're about ready to go digital themselves with it. And we said, well, LML, why can't we do the same thing? And so sure enough, that's what we've done. And so we actually are the first, I think that Warren announced it, it's the first digital standard in systems engineering and program management. So summary of the changes, again, Warren talked about this, but I'll talk about it in a little more detail and go into it and show you more. We added classes, relationships, and attributes from the appendices for the V and V. If you went back and saw what those were, that's the things that ultimately we implemented in InnoSlate as our test center capabilities. Program management was another appendix where we added quite a bit of information to do a better job with getting to the things that people were interested there. I think there's still things that could be done in that area, particularly for EVM and things like that, that would be helpful, that we have explored in the past and we will continue to explore. Another thing we wanted to do was this interface control diagram that we came up with was something that it's the kind of thing you always drew, but there was no standard for it. We at least could not find a good interface control diagram standard. And since one of the most important things to do as a systems engineer is control your interfaces, we thought that might be a good idea. So we decided to add it to the mix and to make it official that it would be an LML standard. We also did a quick mapping of the UAF, Unified Architecture Framework, if you're familiar with that, for the LML diagrams. If you're not familiar with the framework, it has a set of columns. I think they're called aspects, and those represent different diagram types usually. And so we've made it so you can apply different diagram types to it. So it's mapping. It does include the SysML diagram types as well as we see they should be mapped. And one of the nice things is we broke up the standard. So now each individual class, relationship, attribute on the relationship is its own entity in InnoSlate. So it's its own object in the database, which means it has its own unique URL. That means you can go and reference that URL, and that URL will stay stable. Because as we go evolving the standard, we're going to use the branching forking capability to do the evolution, and we can bring back changes that way. So you'll have a unique URL that will be stable to reference. So now, that's always one of the problems, right, when you reference any standard. And the other thing is it is downloadable in an XML format. So it is our XML format, but we have an XSD for that. And we're happy to help people understand how to do that better. It also can be exported as a CSV. Okay, so again, that can be associated with any tool. So now I want to go do live LMLv2, and we were not in PowerPoint. Did anybody know that? This is InnoSlate's presentation view now. And so let me go to the standard itself. Let's see, it's here at V2. So when you receive this, and let's see, is this, no, I'm sorry, this is the wrong one. I grabbed something keeps getting my way here. Let's just do this. There we go. Okay, so we get into it. There should be just these 3 panels on the dashboard. And right now we had a countdown to MBSE-CON. And again, that's just sort of an advertisement for the MBSE-CON. So we will restart the clock for next year coming up. And then you just have access to the specification. So again, those who aren't familiar with InnoSlate, all you have to know is I'm going to come in here and here's how I'm going to read it. I just click in there and there it is. Now, we have set it up so that there is the ability potentially to comment on it. So here, in fact, I have some the fact that we need to update the baseline because this was pretty quickly put up here, and there's still some little minor changes we want to make. When we downloaded this and created the Word document and then the PDF for it, we found a little, word processing kinds of things we'd like to clean up and make better. So that'll be something we'll do before we go full live with this. But again, it wouldn't matter to anybody because it's not going to change the content or the information content that's in the standard itself. So again, as you come in each section, you can navigate here with the hierarchy bar to where you are with it. Of course, you can always scroll as well. If you are in general, we're going to give people viewer access, which means you'll just be able to do all this, but you won't be able to change anything or suggest any changes or add comments. For anybody who wants to, you just have to ask us if you'd like to. We would have to run it through the steering committee to say, yes, that's somebody who's a qualified reviewer of the standard, and we want to make sure we want to get a broad cross section of inputs from people as well. So that's another thing we'll be probably trying to do with it. But there's been a lot of rewrite, a lot of work on this to try to make it better. One of the newer members of the committee is John Metcalf, and he had some wonderful ideas of how to make it more understandable for people who are new to the language. Some of us have been doing it for too long on the committee, so we're kind of happy to get that new blood in, and we've been doing that from time to time. So again, if you're interested in joining the steering committee, that's also possible. So just let us know if that's of interest to you. Plus, there's many other jobs, as we're going to talk tomorrow about what are available in the LifeCycle modeling organization itself. Okay, so there are a number of data types. There's some unique ones here. Computable. This is where you can take and represent mathematical formulas using latex and visualize them as an equation. We've already implemented this in InnoSlate. It's just libraries that are out there and available. So again, software developers should have no problem doing this. So that's why we went ahead and did that. So there's some really big new things in it on data types. Again, you can use this to navigate and simplify things. We grouped the common attributes here, name, number, description, so you can see what those are as separate things with that. Common relationships, similarly. And you'll see that there's a definition, usage, inverse usage. Again, a little bit of inconsistencies in some of the word processing here, but we will be cleaning that up. Go all the way down to when there's an attribute on a relationship. Here it is. And again, to get the unique URL for any one of these objects, open the entity view for it. And that's that unique URL. Okay. So again, the whole idea of a digital standard is I'm not going to make a copy of this thing and put it into a separate database. I'm going to make a live link to the real standard. That's the concept. Okay. This should blow up a few heads about who are still in the document world. So maybe it is a revolution. I don't know. That may be a revolution. So what else we got here? Let's put that down. As we get into the specific classes, each class again has been broken up. Now we've reorganized this pretty significantly because now you have actions, and instead of having a tracking of the in alphabetical order of the classes, these subclasses are associated now right here underneath the main class. What that allows us to do is then recognize that we still have our 12 primary classes of information. Let's get this here. Being able to move this for some reason. I'm not used to a PC, guys, so I'm sorry. Oh yeah, it goes the opposite way of why I'm used to using it. Okay, that makes sense. Anyway, so location, risk, statements, time. Okay, so you still have those classes that you see, the 20 base classes. So we added subclasses again for V&V purposes under action. So if we look at actions, we have for PM we added task, and for V&V there's test case. Okay, and the associated attributes and relationships with all those things. Again, straight lift from the appendices. So if you were using 1.4 and you're looking at 1.4 and you're teaching to 1.4, it's okay, because all the same basic information is there. We've just made it a little bit easier to use, a little cleaned up the language a bit, and so hopefully made it a little more understandable for people. And we're looking for that feedback, because this was a group of us who did this. You know, we're not perfect. We're just engineers like everybody else. And so we did what we thought was the best thing to do. Now we need feedback from everybody to tell us, okay, what did you mess up? and how did you make this? Why did you make this so hard? Visualizations. Again, one of the nice things here is the visualizations are here. So your diagrams, we've done a little bit better job of showing these diagrams, and so they're a little bit better written. These are actual diagrams in the database. This is something you should be able to double click and get to, but they're here in the diagram. I don't know why it's not doing that. So that's another thing I've got to figure out. But they're all here for you. So you can go to the live diagram and see what the live diagram has in it. Okay. And interrogate them if need be. Again, comments are always welcome. Just here's a comments tab. If you have a comment about that diagram, say, why does this look like that? Or why is this not there? Or whatever, what does this really mean? Please ask us.
Okay. What else do I want to show you with this? There's probably a lot more. Let's go back to the document. Just one more time. Nice thing about a browser-based tool, you don't always do the back button, right? Let's hide that up a little bit more. So I think you'll find this is giving you some good examples. Most examples are coming from InnoSlate, but again, I don't know if people know this or not, but we ended up designing InnoSlate to implement LML. Now, that may sound funny, but that's what we did, because what we found was we went out to different tool vendors and they said, oh, that's okay, we got our own proprietary when we're happy. That was the whole idea, was interoperability. We were hoping to get a language that everybody could work with and use across the industry, because nobody was getting to it. Everything that was being created was too complex. I'd worked on the DODAF when it was the C4 ISO architecture framework back in the 90s, and they had something called the core architecture data model. It was huge, hard to understand, very complex, and still incomplete. And then they did the DM2, same thing, huge but incomplete. SysML v2, huge, incomplete. I'm sorry, I keep looking at all these models and they're not the thing we need, that essence of the essential elements of information that help us understand and explain things. Now, so we do have, we did refactor the appendices. The SysML v1.x is still there. I don't believe we did much to that one. Same thing with the DODAF. And DODAF, of course, is being deprecated. If you're not aware of this or not, it is going away. So DoD is no longer supporting it. It hasn't supported it for many years. They gave it to OMG almost, what, 5-6 years ago. And so they haven't supported it for quite a while. UAF is the new thing. And all we're showing here is a mapping of diagram types to the set. So it's not a big deal. We didn't try to map it to the language. That's changing anyway. As I understand, there's going to be a UPDM version 3 being developed that's going to tie back to SysML v2. So again, we're kind of waiting for all this to happen to finish that mapping and updating it. We have done 2 or 3 mappings to SysML v2. We stopped because it kept changing so much. So we just finally said, wait till it's done, and then we'll finally do the final mapping. For those who aren't familiar with SysML v2 mapping, we actually found we did not have to do a lot. We added the equation and port class, equation class and a port subclass. The only ones we had to do in terms of actual classes of information, and then a lot, but there were a lot of relationships, I will tell you, and particularly for equation and port class equations. So there were a lot of relationship changes adjusted for it. So some of which maybe we should adopt. I think we've talked about adopting satisfies and verifies and that kind of thing. I think that's probably a good idea. So again, this is still always going to be a work in progress, and we want to make sure it's a good one as we go. There are APIs, if you weren't aware of that are defined here. So for it. And again, we've used InnoSlate as a test bed for all these things, so we know it works. And we actually have tried to encourage other vendors to pick it up and use it. It's to the benefit of everybody to do that. So, but everybody seems to want to do their own thing. So, and maybe people will accuse us of the same thing. So I guess I should be careful with that. Okay, so I think that's about all I had there. Let me go back to my slide deck, which was in the steering committee one. And just as a preview, I'm going to be talking about conjunctions tomorrow. And conjunctions is, you know how we have attributes, nouns, verbs, adjectives, and adjectives. We are looking at conjunctions for dealing with sequencing. So that's going to be very exciting.
So tune in tomorrow for that. Okay, so let's see, what's the next steps here? I think it's, oh, here we go. So accessing it. I'm sorry, I thought I was done, but I'm not quite done yet. So a paper copy is on the Elmo website already. So if you go to the specification link that's there on the main website at lifecyclemodeling.org, you can download the SysML, LML v2. With it, I didn't. that's how bad it was. I didn't get the link put in there, but it's right there off the website, so you should be able to easily find it. To access the digital copy, just simply get the free InnoSlate account. There's a click here in this, or just go to specinnovations.com, go find the sign up button, top right page, and sign up for InnoSlate if you don't already have an account. Once you have an account, then email info@lifecyclemodeling.org, your username and email address you used to get that account. Okay, and then viewer access will be granted to the standard directly. If you want the reviewer access, please request in your email the short bio that you'd like to do that. And again, the steering committee is going to be granting the reviewer access just to control it for making sure we're getting a good cross-section of folks to do this. Okay, and so next steps, again, obtain community feedback. We want to continue to explore the enhancements of language. One of the things we've been looking at closely is inheritance. We, of course, inherit attributes from the parent classes. We're looking at inheriting values, inheriting relationships too, in actual instances of relationships. So these are something that Mike Delamar particularly has been a big advocate for, as you might imagine. And so we are looking for that purpose. And again, for decision support, of course, the SysML v2 mapping. So with that, thank you. Any questions? And since I'm also the person who's passing the ball here, any questions here? That was so clear that nobody has any questions. Yeah.
I'm curious to see the BNP. You guys mentioned you added some new verification validation.
Yes, so there was an appendix, yeah, I think at the time in SysML 1.4, we just simply took that information and added this part of the standard.
Okay.
Yeah, so there's test cases, I forget whether there's verification requirements, is another subclass of statement that was added, and then all the relationships and attributes associated. Yeah. Yeah. We've been doing that for quite some time, this whole testing side of it. If you want to talk to somebody who's really the test expert, it's Jerry Severs. He's been using it for many years, and he's got a great digital twin with a QSAT that he's developed. So very cool. Take a look at his booth.
I might be oversimplifying stuff, but it looked to me like most of that V2 was just taking all of the changes from those dots and
Yes.
incorporating them into the new standard.
Sure was.
Is that all it was, or was there anything new? So like, if there's somebody out there using InnoSlate on a certain server or whatever, is there any changes that need to happen there or time frame for?
Nope.
Okay.
And we'll be updating, it'll be seamless.
Okay.
Updates. We've always done seamless updates with seamless changes. So you never know. We do it in the background. I'm sorry for you. So, any questions? Okay. Well, we'll get ready for our next speaker then. So, escape. Go. Here. I think that's a new tab I don't need. And let's hide this one. There we go. And so, Nicole, you're next. And we'll just do the usual waiting until 2:30.
Sure.
Okay.
What is it now? 5 minutes?
Yep. Yep.
Any way I can do presenter view by any chance?
That is presenter. Oh, you mean the other thing? No, to see the notes?
Yeah.
No, because then everybody'd see it.
Okay,
They're gonna see whatever you see here.
that's fine.
It's the best we can do. It's just, I know, I wish we could just do that.
Yeah, that's why I have it memorized. It's just
Yeah, oh, good. Yes, yes, yes. That's a very good idea. Oh, here.
Thank you. Where am I gonna put it?
It's a clip, so you just clip, push the clip here and then put it where
Yeah,
you want.
I guess I
Try to hang it.
have to do it.
Yeah, I guess I'd get it as close to your mouth as you can.
Alrighty.
There's an extra bottle of water here.
Oh, excellent. Is it on?
Yeah.
Oh,
So just get you charged up.
that is interesting.
Oh, isn't it?
Yeah.
That's great. So instead of throwing an eraser at somebody, you throw that.
That might hurt.
It's soft. It's pretty soft.
That's not the spirit.
I'm just exhausted.
Oh.
That's the problem.
I hear you.
Yeah.
Is there a clicker or just do it from here?
Yep.
Okay, just gonna make sure.
And you can use the wheel, and sometimes that seems to work too. I don't know. Up, down arrows.
Okay.
April 8th. Have April 8th on here. That's okay. That's
No,
when you got it done.
dang it.
Just tell me you're ahead of schedule.
You know what?
You're gonna fix it.
I will fix it. You will not catch my mistake. Thought I had it right.
By the way, if anybody's taking any pictures and things like that, please post them on the app. There's a place to do that. Love that. We love that pictures. Who knows? We might even get a newsletter out again. Get that newsletter. It goes pretty well, and then we lost our editor. Fun about a volunteer organization. All depend on volunteers. Okay.
What'd you say?
You want to get this over with.
I'm okay. It's fine.
This is good.
Done it
Chill.
plenty of times.
You're chill. Okay.
Thank you. But yes.
Okay, I have 2:30, and we're going to talk with our last speaker of this track. We got Nicole Manno, who's a digital engineer for ManTech's intelligent engineering team, with a focus on leveraging artificial intelligence and machine learning to advance digital engineering practices. He leads the technical development of ManTech's smart portfolio solution to drive the integration of AI-driven tools to enhance the systems architecture and data utilization. She holds degrees, bachelor of science degrees in both mathematics and computer science. That's overachieving, and a master of science degree in mathematics. So,
All right, thank you. So hi everyone, my name is Nicole Manno. I'm a data scientist for ManTech's Intelligent Engineering team. And today I'm going to be talking about how we're enhancing portfolio analysis using both AI and an ontologically backed digital thread solution. And our solution is called the ManTech Smart Portfolio Solution, or MSPS for short. So across government and industries, organizations are facing increasingly complex portfolio of systems. Data is spread across spreadsheets, documents, databases, system architecture models, and organizations are spending far more time tracking down the data and reconciling any inconsistencies rather than doing any actual portfolio analysis. And even worse, with the increasing usage of AI, outputs or LLM outputs could feel like a black box in that we don't have much context as to where the LLM is generating its context from. So while organizations are attempting to solve these problems through methods such as dashboards, spreadsheets, etc., and while these solutions may work for simple tasks, it tends to break apart when the problem scales and the portfolio of systems becomes far more complex. So without semantic grounding, in reference to AI, the AI outputs could be disconnected from the operational reality. And without traceability, decision makers can't confidently defend these insights. So this brings us to the ManTech Smart Portfolio Solution, or MSPS for short. And MSPS is designed to address these exact challenges. So MSPS is an analytical platform built for portfolio analysis that leverages both AI and an ontologically backed digital thread. And this combination allows us to connect capabilities, systems, components, and unstructured documents all within a trusted semantic framework. And MSPS is offering 3 tools, which I will introduce shortly. But before I do that, I do want to talk about what is at the heart of MSPS, which is our ontologically backed digital thread solution, the EDF. So the EDF integrates heterogeneous data from different sources, such as system architecture models in Cameo, Jira, MATLAB, GitLab, CAD, and unstructured documents, all within a knowledge graph. And AI leverages this knowledge graph to ensure that every recommendation that is produced by an LLM is grounded by some source documentation or your user data. So this is what makes MSPS trustworthy, scalable, and also interoperable. So with that being said, I'm going to go ahead and introduce the 3 tools that MSPS is offering. So the first tool that we have is the obsolescence management tool. What this tool does is that if you have a system containing component data, we can go ahead and find obsolescence risks associated to the components within your system. So this could be finding end of life dates for your components, or this could be predicted risk associated to your components. In addition to being able to identify these risks, we also provide replacement part analysis and trace the potential impacts that risk could have on your system and your portfolio systems. So this allows organizations to not only be on top of any obsolescence issues, but also mitigate its effects strategically. And because MSPS is built on the digital thread and we provide the obsolescence management tool in MSPS, we can trace all the insights back to your source documentation. The next tool that we have is the digital thread chatbot. And this allows users to ask natural language questions about their data within the engineering data fabric. So this includes Cameo Systems Modeler, Jira, GitLab, etc. we're able to ask questions, for example, for Cameo, we can ask questions like, what is this model about? Can you describe what is going on in this diagram? Could you explain the containment tree structure that we have within this model? But because also MSPS is a tool that is focused on portfolio analysis, we can also ask questions like, which capabilities are impacted if system X is retired? So the chatbot will consult the knowledge graph to make sure that the recommendations or the insights that it's generating is grounded in the user's data. So really, the digital thread chatbot brings the power of the digital thread to non-technical users, and it lowers the barrier of entry to their data. And the last tool that we have is the capability optimization tool, which solves a key challenge in how can we configure our systems to cover all required capabilities while also minimizing total operational cost. So with that in mind, we also provide intelligent links from your capabilities, and this could be provided in, say, like DODAF architecture, and we link those capabilities to the systems that you have. So this allows decision makers to get transparent recommendations with complete traceability so that they can make trade-offs confidently. So those are the 3 tools that we have for MSPS to begin with, but as the platform develops and we have different customer needs and requirements, the tool will expand. So before I jump into some examples of what the platform does look like, I do want to provide a use case example. So an analyst can go into the platform, and beginning with the obsolescence management tool, they can perform an obsolescence assessment for their system of interest and identify any obsolescence issues that they have within their system. Then they can go into the digital thread chatbot and figure out and trace the systems and the capabilities that will be affected by that particular part being obsolete. And then finally, that analyst can go into the capability optimization tool and figure out some type of configuration of their system covering capabilities such that it will minimize both risk and cost. So I'm going to go ahead and just jump into what the platform looks like as of today. So at the top left, we have a notification window for any obsolescence assessments that were conducted. And if anything were to be found, the system will notify the users of any potentially impactful end of life or risks associated to the system. We have a data manager, and then of course we have the different tools that the system offers. So starting off with the obsolescence management tool, we require for the tool to work system component data as an input. And that input could be provided as a system architecture model in Cameo. It could be provided in a BOM in some type of tabular format, or it can be provided within an engineering drawing. So to be able to do the search, to be able to find any end-of-life dates, we require some type of searchable data. So in this particular case, we have model and vendor data that we're able to search for the end-of-life components for. But we could also utilize part numbers. We can also utilize national stock numbers or NSNs. So if the user wants to perform the obsolescence management from a system architecture model like we have here in Cameo, the user can ingest this model into our EDF and then go into our platform, which is a web application, and initiate the assessment. And this assessment could be done on a schedule. So every X amount of days, the system will automatically perform the obsolescence management assessment, or it could be done ad hoc, so just by initiation. So when an assessment occurs, the user will receive a report, which will look like this. So on the left, we have a summary of details of what was found in the assessment. At the very top of the image or the screenshot that I have here, we have a donut pie chart that breaks down what exactly was found within the assessment. So we have information about components that were already obsolete. We have information about components that have a future end of life date. And then we also have a third category for predicted risk, which could come in different flavors. This could be based off of historical vendor data. Your component could be at risk of some type of supply chain issue, for example. We have a natural language text summary that was generated by an LLM. And then we have the component breakdown. So if the user were to click on any of the rows within this component data table, a new window would pop up that actually breaks down more information about that component being at risk within your system. So at the top, we have information that was provided by the data source. And then below that, we have the assessment results. So the component that we have on the right was already found to be obsolete. So we provided an end of life date. And we also provide the link to that source that we found that date from, so that users can go into the platform, and if they want to check to make sure that that date is correct, then they can go into the link or whatever source that we found the information from and verify that that is correct. And then we also have, again, another natural language summary, but this breaks down the risks associated to that part being obsolete, as well as potential replacement part information. The next tool that we have is the chatbot. So again, chatbot is we're able to ask natural language questions about the data that we have. In this particular example, we are using the same model that we used for the obsolescence management assessment. But now that we have done the assessment, we can then go into the digital thread chatbot and we can ask about its effects of that obsolete part that it has on our system. So when we ask that question, the chatbot is able to identify the systems and the components that are affected by this obsolete part, and also tell us which components are connected to that obsolete part. And this is part of our replacement part assessment, trying to figure out really if this replacement part could be compatible based off of the part that you have within your system architecture model. And then the final tool that we have is the capability optimization tool. So the capability optimization tool requires system architecture as an input. This could be provided within a DODAF model, where you have your system viewpoint in SV5B and your capability viewpoint in CV6, I think, where we have some type of mapping between the capabilities within the DODAF architecture and your systems and your DODAF system viewpoint. So the first part of the tool, in this screenshot here, we're tracing the systems and the capabilities that they cover. And then the second part of the tool is the actual analysis. So the first part at the top of the screenshot, we have information about the gaps and overlaps of the capabilities. So the gaps being the capabilities within your portfolio that aren't covered by any system, and the overlaps being the systems that are covering the same capability. And then below that, we have the recommended reallocation of the systems covering particular capabilities to minimize the total operational costs. So the benefits of MSPS can be seen across the board. For users, it provides faster, more intuitive insights to their data. For teams, it ensures that portfolios are better aligned to their objectives and also better protected against risk. And then for the enterprise, it helps achieve measurable cost savings. So to conclude, MSPS provides trusted AI-powered portfolio analysis that is grounded in semantics and is built for real decision-making. And it helps organizations make smarter, faster, and defensible decisions. So thank you.
Yeah, are there any questions? Come on, don't let her off the hook too easy. Oh, you got your boss asking you a question, now you're in trouble.
He's not my boss.
We got a boss.
What I was gonna ask is, earlier in the slides, you mentioned about how the system would automatically connect capabilities to systems, determine what the capabilities of the system are.
Mhm.
Where did you get the capabilities from? And how do you automatically connect them?
The capabilities need to be provided by the users. It's what the user identifies as a requirement for the portfolio of systems to provide. So that could be provided within DODAF architecture, for example, within your capability, I think CV6 viewpoint. Yes. And now we can do the analysis where we can, holding a napkin, sorry, automatically link the capabilities to the systems. We can do that analysis. But the user can also provide that information through, I think, a dependency matrix. I'm sorry, I'm not a system.
So the users can provide the existing mapping that you can just suggest.
Yes.
You're saying that's one way.
Yes.
Or you're using like an LLM to be able to look at the description of the capability, description of the system, and say, oh, that was to match.
Yes, and it's obviously far more reliable to have the user be able to make that mapping. Really what the important piece of the capability optimization tool is to be able to provide that recommended reallocation so we can minimize the total operational cost. Yep, thank you.
Questions? Oh, yes.
I'm wondering about the DODAF models, if a program has an order limit, a PDF or just images instead of a Cameo model, can it handle that?
We are, right now, no. But with the further development of the EDF, we are expecting to be able to extract data from unstructured documents and be able to place that into the knowledge graph where we actually do the assessment on. But that'll come in the future, yeah.
It's too early. Second?
Just a quick question on the digital thread tool.
Yep.
And with the chatbot and its interrogation capability, are you dependent on digital thread between tools already being built and then interrogating along the thread lines that have already been built? Or does it help build that thread between to interrogate data across multiple tool sets?
I'm not sure if I
We can chat later and draw it out on a whiteboard or something, and just at least, I'm curious if it helps make the digital thread, or does it use a digital thread that's already built to answer the user's question within the actual
Okay.
tool?
My apologies. It's the latter. Yeah.
Thanks.
Not there yet. Right. Anybody else? Questions? Come on. Say, now you're not ready for a break quite yet.
I don't know.
Did you have something? Over? Okay. Oh, my. Hey, welcome to you. Yep, my job.
Some
Exercise program.
I was trying to get to the ManTech website. Do you have other projects? Other capabilities that ManTech has as an organization?
I'm sure of it. We do have a portal that includes all of the capabilities that we're currently creating within the different practices that are aligned within ManTech. I don't have a link on hand, but I can find it for you. And yeah.
Well, it's on your website.
Okay, great.
So I'm always interested. I noticed you have careers, so my students are always open to career opportunities.
Okay, great.
So let me ask a question, I guess. So if I gave you my XML from Manno, where I have all that data information mapped and all the information there, could your tool ingest that, find the problems?
So we don't actually take any files as an import into our digital thread. We have an adapter that sits on top of the tool that like extracts the information.
Oh.
So if that tool or if that file exists in like a system architecture tool like Cameo or is Rhapsody?
So, you know, Slate?
Yes.
Yeah.
Yes. So yeah.
I'm in a Slate guy.
Yeah, yes. So it depends. So to answer your question, we would need just to apply an adapter on top of the application.
Okay.
But it's not a hard push to do something
Okay,
like that.
good. Yeah, let's talk.
Okay.
I'd like to do that.
Sure, certainly.
I love what you're doing, so it looks like great
Thank
stuff.
you.
Yeah,
Okay.
we've been exploring all kinds of things like that ourselves, and there's just so much to do. It's always good to be able to leverage other people's resources.
Absolutely.
Anybody else? Anything else? I didn't see anything online. Okay, we'll have to let her off the hook. Thanks. Thanks, Nicole.
Thank you.
Okay, so we're going to be taking a half-hour break. We're gonna meet back at 3:30, and then we'll have the trivia contest at the end of the next sessions. It'll start roughly around 5 or so. We'll probably give people a few minutes to get drinks before we get it all set up and going. So just be aware of that. It may not be instantly at 5 o'clock. We highly recommend if you, it will be 5 o'clock on the East Coast at least. If you're online, please go ahead and bring your own booze. Okay.